I totally agree. And I think, one of the important things to call out about our approach is that we try to meet people where they're at. So if you have existing hardware that you want to utilize, and can utilize, it's in everybody's best interest to try to take advantage of that, so that we can, build some solution and get to the outcomes that a client needs without introducing unnecessary costs.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, the value of enterprise architecture with special guest Ben Kotvis, Principal Solution Architect at Insight.
Ben, welcome to the show.
Thank you.
Hey, Ben, it's been a pleasure working with you. You work at Insight. I've had a lot of fun working with you. I always like talking to other architects. You're a principal architect at Insight because we can really bounce crazy ideas off of things and really start coming up with really good solutions. But before we get into, talking about enterprise architecture, Ben, who is Ben? Why, my audience wants to know, who is Ben?
Well, as you said, I'm a principal architect. I have been working in technology for about 25 years now. I started with kind of an SAP conversion for the year 2000 when we thought the world was going to end because all the computers had only 2 digits for the year.
It was going to end, Ben. Come on, it was going to end. You saved the world.
I like to think so. Maybe I spend too much time thinking that, but and so getting familiar with technology early in my career, and I guess being in a situation where I just happen to have a knack for it. I got to learn how to write software. Kind of started in the database layer. I'm pretty comfortable with dealing with T-SQL and writing indexes and optimizing queries. But then I got into hardcore Java and .NET software development, and now, boy, it seems like every other day I'm learning a new language, and really enjoy just kind of getting my feet wet and getting familiar with different platforms and finding out which ones work for which situations the best.
So you're kind of a jack of all trades. You can do the data layer, you could do front end stuff, back end stuff. It sounds like you could do a lot of things.
I like to do that. Maybe some would say I don't know my limitations or I'm too confident, but I just like I don't like to be limited by some, kind of artificial boundary. I like to understand how it all works. And if something's in my way, I just like to knock it down and move on.
So Ben and I are cut from the same cloth because I'm a systems guy too. I like to know as much as I can. I don't necessarily need to go super deep. I write horrible SQL queries, by the way. But I'm really good with DevOps. So DevOps is my forte. But it's good to have a touch. And because you and I are kind of cut from that same cloth, we both talk a lot about the benefits of enterprise architecture, the benefits of tops down systems architecture. And that's kind of what we want to address today is the importance of it.
Right.
So what would you say if someone said to you, Ben, why should I have an enterprise architecture? What would be your first thing that you'd say to them?
I think it's important when you're working on technology for an organization. We think about kind of an enterprise or maybe government, large organizations that have technology problems they want to solve. You want to have a good set of opinions on how things should work. And these days a lot of people are working with microservices, and so having opinions about how those should work, or adopting the opinions of leaders in the industry, or just common understood opinions is a good thing too. It's always, those are moving targets, and so the things that we may have identified as the best of practice a couple of years ago is going to be a little bit different these days. And so I think having those opinions and providing those kind of benchmarks for people to work around. So, for example, 12-factor apps is something that is a really good set of guidelines for people these days when they're building enterprise architecture that puts those boundaries around and those opinions in place. So when it says, okay, well, how are you going to deal with just kind of writing output into logs? Do you want to have a process that's got some direct attachment to an API and is going to break your entire app if it can't connect to that in real time? Or should this be some asynchronous process that will scoop in those logs as needed? And by the way, while you're doing your development, you can also read those same exact logs in console out. And so opinions like that in 12 factor, I think, is a really good kind of example of where enterprise architecture can take some of those guidelines and those opinions and put them in place, because they'll help you when you do scale out. And you and I have been around long enough to know when we would run an app on a single server, and you would you didn't have to worry about the same kind of things back then. You just
No. It's
like,
well, and that's an interesting. I'm glad you brought that up, because a lot of people say, "I just put it in microservice, it's done." Right? That's the architecture, is microservice, but we've learned, right, that that's not
right.
true. And there was a major outage at AWS in 2021, and the week of Thanksgiving. And which is the absolute worst time to have a major outage if you're an e-commerce site, right? Major outage, and it was because one service went down. It was their monitoring service. It went down, and everything depended on it. And no one knew that it went down, because the thing that told you that services went down was the monitoring service. And it was so tightly coupled that no one knew. Except that my app wasn't working. So when you go and check, it showed everything was green. So you thought it was your own code. It was a major problem, and showed a huge vulnerability that we have in the industry, because this is not just AWS. This is in the industry as a whole, that we're not looking at system architecture like we have in the past. We've kind of just relegated that, hey, if I have a microservice, I'm done. And what I love how you brought up the 12-factor concept, right? Because we do need to get back to some of the fundamentals of enterprise architecture.
And like you said, a single point of failure is probably the most common thing to cause an outage. Maybe second to certificate expiration. That happens.
Yes, I've run into that recently. I ran that on a critical day. I was pushing out my my podcast, and my certificate expired, and I didn't know. And all of a sudden, I can't push, and I go, "Oh, what's wrong?" And it took me a while to find out. So I wrote poor code. Right? That's poor. That's awful. Why would I do that?
Well, it's not probably a system critical problem that you're necessarily trying to solve. Like if there were billions of dollars on the line for it, so
No, there wasn't. Yeah, my podcast doesn't have billions of dollars on the line. Not yet. It will. The more people listen and click on my advertisers. Make sure you do that, right?
Absolutely.
So let's talk quickly about kind of the work that we've been working on together around coming up with a generalized, I don't even like to call it a reference architecture. To me, it's a conceptual architecture on how all these different pieces fit together that we see in enterprise, both in government and outside of government, that we're seeing, because there's so many tools that are just being glommed on to IT. How do I know what fits where and all that stuff? That's kind of the concept behind it.
Yeah, I think the idea of bringing all of these pieces together and having a logical bucket to place all of the technology, so that as you talk about it, for a company like Insight, we have a lot of different partners that we work with, and some of them have they overlap in different spaces, and sometimes they're competitors. And in some scenarios, you're working with a particular organization, they have a relationship with one of your partners, and they may not with another. And so you want to have some flexibility on how you execute on those particular pieces. And so when we come together with this framework, part of that is really having, kind of the opinions we talked about before, but understanding what those logical buckets are, so that we can place things in the right places. And as we communicate them about, language is so important, right? So as we communicate about those logical buckets, we can say, all right, well, this is the physical layer. So we have to have the concerns about what servers we're going to have, what infrastructure we're going to have. Are we going to write to disk, or are we going to just have it in memory and hope that it doesn't, that we don't lose it? And so, those having those concerns and being able to communicate about them effectively because we're using the same language is really the way that we can help our clients achieve the outcomes that they want to achieve, because we've kind of plugged in the right pieces into those logical buckets with solutions that can achieve those outcomes.
So why don't we delve into the different layers a little bit and find out, kind of explain our approach to it. Does that sound okay?
Yeah.
You all right with
Yes.
that, Ben? All right, so let's talk about the physical layer. So this is the bottom of the stack. If we talk about the physical layer, you mentioned, hey, hardware, but nowadays our data centers don't have walls anymore. I've got hardware all over the place.
Right. Yeah. And I think where the hardware is probably is less of a concern than it ever has
Right.
been. However, how much control you want to have over that depends on your kind of use case. So if you want to have complete control over that because you have some particular hardware optimization, which in some cases is necessary, and in some cases is just a luxury that you want to take advantage of. And in those cases, you'll want to be able to kind of take advantage. I mean, AI is a great example of that, where you are potentially forwarding a GPU into a particular container so that it can operationalize that workload with access to that GPU. In hopefully you don't have to do that a lot, because that does tie your hands in a substantial way.
Yeah, it does.
It makes it a lot
Yeah.
less portable. And as someone who has spent the last couple of weeks trying to use WSL to take advantage of my GPU on a Windows machine, there's a lot of hoops to jump through to make that happen. And that's a little troubling and challenging. So, I think the portability and the flexibility of hosting options is great. And the more that you have that flexibility, it kind of backs into what we were talking about before. The more you follow the standards about distributed architecture and distributed computing, the more you can have some flexibility and indifference about where some of your compute is running. But there's maybe an 80-20 rule there, where 80% of the time you can deal with the indifference, and 20% of the time you really do need specifics.
So I like how you said that we need to be flexible to handle both those cases. And the 80-20 rule is absolutely here. A lot of software developers, though, I want to know everything that's running on all the silicon I could take advantage of. But in reality, I don't. Right? I mean, when push comes to shove, is it going to run in the SLA that's been specified or not? And if it does, then who cares if it's a little bit faster? It meets the criteria that's required. So that physical layer and understanding the devices that are down there, their features and functionality is important as I move up the stack, right? So that I can land applications or microservices on appropriate hardware, whether it's in the cloud, in the data center, or out at the edge, or it could be a PC, it could be a phone even nowadays. It's kind of crazy where compute has led us to.
I totally agree. And I think, one of the important things to call out about our approach is that we try to meet people where they're at. So if you have existing hardware that you want to utilize, and can utilize, it's in everybody's best interest to try to take advantage of that, so that we can, build some solution and get to the outcomes that a client needs without introducing unnecessary costs. And so I think that's a powerful piece of this approach to me, is that we're not saying, hey, we've got to just kind of scorched earth start over from scratch, but hey, you've got some existing hardware that meets a particular criteria, or we can break
leverage it.
workloads into different criteria, and so those workloads are appropriate for that particular compute that you already have.
So let's talk about the next layer up, which is I call the software-defined infrastructure layer. This is what actually lets me deploy, applications effectively, right? I can provision stuff. When you hear software defined infrastructure layer, we typically think of VMs, right?
Hmm.
But it doesn't necessarily mean VMs. It just means I can provision hardware for specific uses, right?
Right. Right. And, there's a lot of platforms that are partners that we have that help us with these. So we've got like Ansible, we've got OpenShift, we've got Puppet, a lot of players in this space that are able to help us get these workloads off the ground. And like you mentioned, it's not always going to be virtual machines. Sometimes it's going to be containers, and some platforms are kind of going to just get us starting there with contain kind of a baseline where we're just pushing containers and those workloads into that solution stack so that we can get off the ground without having to be concerned about each virtual machine in the operating system and keeping those operating systems up to date and doing the patches. And so there's an advantage to that in the sense that your containers kind of dealing with those needs at the application level. But when you put
But
those,
what if I don't use containers? Hey, just a second. But what if I don't use containers? Can I still take advantage of that software defined infrastructure
oh,
layer?
for sure, yeah, and the fact that it's often committed in your source control the same way as code is very powerful because you can always roll back to different versions. You can see what changes have been made. I mean, it's just funny because back in the day, wow, what a mess! It's amazing that we all had jobs because the way we would deal with deploying, you putting in
Oh, I
variables.
know. I used to be at 2 a.m. going, why did I run out of disk space in the middle of a build? Or where's that configuration file? Right? Or what, you'd sit there and you'd hand tweak one box to get the build to go through or to get a background office, job running, whatever the case may be. It's amazing.
Yeah, just and God forbid anything went wrong on a physical device that you didn't have well scripted, and you're like, okay, you had to put a new hard drive in there, and you're doomed. I mean, you have now sunk days into getting this back into the state that you think it was in, and
Yeah,
so
exactly.
we've certainly
So,
come a long way.
so with the software defined infrastructure layer, this now becomes as code, right? Infrastructure is code, basically. Much more repeatable, higher quality. There's so many benefits to it, right?
Absolutely.
Okay. All right, cool. Let's go above this. So I've got my software defined infrastructure, my data center. This can handle in the cloud, out at the edge, in the data center. It does multi hybrid cloud, blah, blah, blah. That means nothing without being able to drop applications and services on top of it,
Right.
right? Explain a little bit about what we're seeing in that space.
So when we kind of come up this level, now we have our applications that can be distributed in a number of ways. And this is often where, for me these days, I'm writing a lot of containers because that's just a really great way to encapsulate your app and whatever dependencies it has. And I think, in our organization, we have a team that's called a platforms team. They actually do the kind of encapsulation in the software defined infrastructure layer, and they write that code, and then we often are writing the code that the apps are. But who's responsible for what? There's not a real obvious dividing line because the dependencies for an app are usually in the container image, and you're saying, hey, I need Python and I need these pip packages and I need to install them, and that gets the app up and running. And back in the day, it was like, okay, my code compiles, good luck, figure out how to make it run on the
Yeah,
server.
you ship it off to IT, install this on a server, and they're like, well, it doesn't run because it has the wrong version of Python, doesn't have all of the pips in there that are needed. Right? Whatever the
Yeah.
case may be, the dependencies aren't there. Now, this is cool, right? Because everything's encapsulated in.
Yeah, and we have all the options like Kubernetes and Docker, and I mentioned OpenShift before on these platforms that actually can run these workloads, and you can scale different instances up and down. And this kind of comes back to the distributed computing, where you've got to write it in a way that there may be 10 instances of this running or 80 instances of this running, and you better count on that and understand how to build it so that there's not some collision or some just assumption about the way that this is going to run with one instance running at a time. And so there's some platforms that really help with that, and in architectural strategies, and it kind of comes back to some of the 12-factor pieces that we talked about before. But as you encapsulate those containers, kind of the classic concerns of distributed computing come back, but we have the ability to kind of run those on these platforms that help give you the ability to tweak and configure your solution so that if you need 10 instances of, let's say, some machine learning container running, that you can do that. Or if you need an API that's going to be able to run 50 instances or scale up and down as needed because the workloads aren't consistent, that can save you money. And so those concerns can be added, and those kind of, some of those that I just described are still in that software defined infrastructure, but then they're playing into how you write the actual apps in the service management layers.
So this means that I have to up my game as a software engineer and understand the complexities of distributed systems. That's going to be critical moving forward in this world where I don't know where my application is really going to run. It could run out on the edge in a smart camera. It could run in the data center. It could run in the cloud. So I need to write better code, basically.
Yeah,
and understand distributed systems.
Right. And I think, like, for me, my observation is probably the biggest paradigm shift for application developers is really kind of the transactional boundaries of consistency, and thinking about, back in the day, we'd think about distributed transaction coordinators when we had, multiple instances of things running, and you wanted to have a transaction that was going across multiple systems. That is a horrible way to develop things these days. It's just unattainable, really, with the difference in physical architecture. So pub sub and kind of eventual consistency has really taken charge and really given people that flexibility to write applications in a way in microservices that can communicate and scale and give you the outcomes you need very quickly without having some of the collisions that you'll have and the inconsistencies, not the inconsistencies, but the deadlocks you'd get back in
the deadlocks. Yeah. And inconsistencies too, right? That's a major problem. How do I handle then if I've got legacy systems, Ben? I mean, no, very rarely do we run into a customer that has completely greenfield. They typically have a mainframe somewhere, in a closet down in the basement of a building with, some gray-haired guys that still keep it running.
Gray-haired.
But they still have to interface to it. How do they do that with these new modern techniques?
Yeah, I think, obviously we can't rewrite everything. And this kind of the statement I made about meeting people where they're at is really an important one, because organizations are starting to move some of those mainframe applications into the cloud, and they have some more flexibility around where they run, but they're certainly not going to rewrite everything. And so they need some flexibility there to take advantage of the existing code they have while modernizing when they can modernize. And so in some cases, those old applications, like, if you're talking about something that does have that kind of consistency, well, you almost have to, kind of have your other systems throttle things back so that it can accommodate those old systems in a way that will keep the consistency that legacy system needs in order to maintain the integrity of your solution space. And so it's not a this is a balancing act. And I think, honestly, if in technology, this is the space that's probably going to be the most lucrative in the next 5 to 10 years. If you can work on deal with old legacy applications and figure out how to make them work, and while modernizing the rest of the solution space, I think that's a big area of opportunity, because it's hard. It's very hard, and you have to be talented to make it all happen.
So one thing we haven't touched on, and it is a problem with distributing, with these new architectures, with distributed architectures, is data. There's a perception. In fact, it's an assumption that the Kubernetes developers made was that the data would be accessible. But that's not true.
Right.
Not even close, especially in highly distributed architectures where I've got data out at the edge being generated, and it's just way too much data. So this is where the concept of our distributed information management comes in, and this data management layer. Very new area. There's lots of really cool architectures out there. What would you say to enterprises or government agencies that have data silos, have data scattered all over the place? What approach should they use? I mean, how do I even start?
So yeah, you bring up a really good point, because you can't pull all the data in all the time. That's not practical. Early in, kind of my cloud distributed computing career, I would do a lot of like hybrid connections where you'd essentially have like a socket or something like that on premise and then say, hey, give me this data. And that's fine for like a small API call, but it's not practical for large scale, like big data type.
Yeah, terabytes of data.
Absolutely.
Right.
Yeah. So I think what is attractive about our approach is really moving compute to the data, and kind of leveraging that data gravity that's pulling kind of the compute to it, and having the flexibility to use that compute where the data is at, and so that you can get those insights from that data, and then move the insights and in smaller pieces and more manageable pieces, as opposed to saying, okay, all the data's got to be here for me to crunch it, and use something like Databricks or Hadoop or whatever the big data platform of the week is, and take all of that information and make something meaningful with it, assuming that I can create some kind of HDFS connection or whatever the connection type is to kind of centralize that in a way that I can get to it. It's just not practical, and there's also security challenges around making that so available to a tool like Databricks or whatnot. So you have to have the flexibility to say, okay, I got to get to that data in a different way. And that may mean a paradigm shift of saying, take that compute, move it to the data, as opposed to the other way around.
Well, and we talked about this. It has to be flexible too, because every situation is unique.
Mm-hmm.
And what I have found, I've done a lot of work in Department of Defense. Not only every situation is unique, that situation changes depending on what's going on in the environment.
Right.
So sometimes I want to move the data all to a central place, and other times because maybe my connectivity is bad, maybe I'm in the field of battle where I can't do anything, I want to run the analytics out at the edge. So this dance between the service management layer and the data management layer and the infrastructure management is this new concept, I think, that has to be more dynamic. We can't statically lay these things down like we have in the past. It's just too complex.
Yeah, and I think that when the cloud and IoT types of, I was in a lot of IoT conversations years ago, and it just seemed we took a very simple approach. I'm getting all the data. You're giving me all the data.
Yeah, I can move all the data to the cloud.
I don't care how much there is. We're just getting it all into one place, and we're going to figure it out from there. And ultimately, that's kind of how edge computing was really kind of popularized. Is like, well, wait a minute, do I really need 100 temperature readings a second in a manufacturing solution, or do I really care if it's outside of a boundary, or can I make an average or something like that? So there's a lot of I guess realizations that we've all had over the years of how practical this is going to be and how much data there is that's being generated on a regular basis.
It's just incredible.
Right.
And you can blame Intel for that. We create a bunch of processors that we stuck out at the edge, and it's doing a wonderful job generating data.
Yeah, it's true.
And
it's good information. It's just a matter of how much can you really afford to store for the rest of your life. That's really the question of the day.
Well, and the data scientists will say, well, I don't know if it's good yet because you haven't told me the use cases yet. Right. So yeah, there's this fear. If I throw anything away, I might be missing out on $1 billion or $1 trillion opportunity, or a new way of understanding how to serve the citizens or my constituents, right? Or to fight a battle better in the Department of Defense. It's this crazy thing that we do. We hoard data in a big way.
Yeah, it's kind of interesting because I wonder how often the data changes, and there's so many variables when it comes to data, right? So you can have, obviously, it's times, seasons of the year. There's so many things that
Yeah.
can have an impact on data, but ultimately, there is a cycle that things repeat themselves. So, for example, you take like enterprise systems that have had data coming in, mostly like the year 2000 was maybe the time where people are like, hey, we're going to collect everything because we can do really interesting stuff with this data eventually,
Right.
and nobody's done anything with it over the last couple decades. And so, now we're in this situation where, well, we should probably be more strategic about how we capture the data and what we're going to do with it. And I think we're starting to see where people are becoming outcome focused, kind of to your point of what
Yeah.
is it that we want from this data? And then let's figure out what we're going to collect and see what a good sample size is for that and how long we need to collect it. Because is there an anomaly from 5 years ago? Maybe. And it'd
Maybe.
be great if we had that information, but do we want to capture it forever just in case? It's a hard question.
This leads to the next layer, which we call the applications layer. This is where you're really developing applications or application workflows, right? Through your process. This is where I meet with the use cases and the capabilities of the agency. This is where I do my development of and tying microservices and data and all this stuff together. This is to me the hardest layer.
Yeah, there's a lot of complexities in it for a variety of reasons. When you think about kind of the development environment itself, those can get really complicated. Like, how do I
Yeah.
interact with my code? How do I, as a matter of fact, like building a microservices solution, you have a couple options. You can try to have like 10 services running in your IDE at the same time. That is hard to manage. It works, and boy, it's predictable when you deploy it, but maintaining that is actually
A
probably
nightmare.
more work than it's worth.
Yeah.
So then the question is, okay, you develop, each service independently, and you know, publish a message and assume that your inputs and outputs are correct, and then you deal with them in smaller pieces, and then the development environment's easier to manage, but you have a little bit less predictability. And so, as microservices mature and you see opinions starting to form about this, I mean, I have my own, and I'm not in the same place I was when I started, because I've gotten some scars and bruises from some of those things. And but it's an interesting space, and the complexity of building them is interesting. And then and on, like, in the AI space, we have kind of a significant problem of the IDE that's used, the Jupyter notebooks, and moving that into executable code.
and making it production worthy instead of a notebook, which is a data scientist notebook,
Right.
right? It's a notebook. It's not production worthy stuff, right? That's a big problem.
Yeah, and I think that's as we see more AI use cases getting more practical exposure, we're seeing that problem come to life. At least at Insight, it's like, okay, this is a problem that we're going to need to really get under our feet and help our clients with, because they need to build AI and they need to understand how to run those experiments and then take them into something that can, you know, let's not use the local disk deep in our code base. And you and I, we write code, so we're thinking layers of our code. I call this at the top layer down into the lower layers of the code, and if I'm accessing something on the disk somewhere deep in the code base, it's just going to create a problem later. I need to
Oh, well, yeah, it's not portable all of a sudden, right? It
exactly.
can't move. No. So, all right. So, encompassing all of the application layer is really complex. It's DevSecOps, it's MLOps, it's RPAs, it's tying all this stuff together to do process automation and all this. But and I hate to say this last because it really should have been the first thing we talked about was security. I can't do any of this stuff without doing it in a secure domain, because especially with a data center without walls, where my data and applications live in the cloud in the data center out at the edge, my footprint, my attack surface is vast now, massive. So I got to do this all in a secure domain.
Right. And there's a lot of tooling, and I feel like it's not consistent anywhere as far as how people really put these solutions together and where the security lies. And what I like about this approach that we have and this stack that we have is that we've got kind of identity and security as cross-cutting concerns. Identity
Yeah.
could be a person, an individual, like with my account in, let's say, Active Directory or Okta or something like that, or it could be a device. And it could be, a device with an identity that's accessing systems on behalf of that device's identity. And you have the same types of security concerns, and they have different roles and different access levels that they need to have the ability to kind of get the information they need and interact and integrate with other systems. So when we think about the different layers, you've got the hardware aspect of things like virtual private networks. You've got maybe software defined wide area networks. You've got some of these things that from maybe a local office, you want to connect to a central office, or when we think about government systems, you might want to be able to connect some remote vehicle to execute and to communicate at certain levels. Maybe sometimes you need a really high level of security, maybe a specialized VPN for certain communications, and other times you might be backing that off into a different layer that doesn't need to be quite as secure. And so the ability to use some of our partner tools, Palo Alto, Fortinet, and some of their ability to provide those security levels in a physical way, with physical devices. And then in some cases, you will need to take advantage of software security. And I think where our partnership with Intel is really important is that is really a first-class citizen of the hardware. And so we can really use that hardware's encryption and things like hardware security modules, and use that
And
to
a hardware root of
hardware
trust.
root of trust
I can trust the hardware. Yeah.
to
So I think it's really cool that we've been able to work on this stuff together, and how it's all tied together. I know when I've gone out and talked to customers, it really rings to them. They understand. They can see where their stuff fits in here, and we can easily identify gaps that they may have in their current infrastructure to help them move forward. Are you seeing the same sorts of things, Ben? Now, I mean, we just launched this last month or so.
Absolutely. I think, at the end of the day, having these opinions and being confident about the ability to execute on them is actually not that common. People are afraid to go into these spaces because of the complexity. How having, okay, I've got this system. I think often it's like, okay, we would just want to focus on this very narrow thing and just assume that nothing else exists and build out
Oh,
that
yeah,
particular
that's
outcome.
bad.
It's unfortunately it's true.
But that's what people do. No, you're right. That's what they do.
And so because of that, you end up with these silos that are just not well integrated, and inconsistencies on every layer of the stack, and even, particularly like in the security area where that's really risky and the worst place that you want to have inconsistencies. So when we think about, okay, how do we bring this together? I think, again, one of the more powerful things is that we're meeting people where they're at. So we're not just saying, hey, we've got to overhaul everything, but also having something that's kind of crossing the boundaries of saying, okay, well, here's a problem space you have to deal with, and here's how we've dealt with it with other people and other organizations with these types of problems. And these are the partners that we work with to get this done. And we've got experience and they've been successful. So we expect you to be successful as well.
No, this is awesome. Ben, it's been great having you on the show. We most definitely are going to put together a series, you and I. We'll go through each layer in depth.
I love it.
Because we got to geek out. So I need some time to geek out every once in a while. So
when do I get
I
to pull up
appreciate you
my
coming on
IDE?
the show today.
That's what I'm waiting for.
You're waiting for what?
When do I get to pull up the IDE and we can do some code review together?
Yeah. Oh, there you go. There you go, man. Except I'm an IntelliJ guy. You're going to have to come to the dark side. Overdo IntelliJ.
Okay. I'm willing to try it.
All right, cool. Hey, thanks again, Ben. I appreciate your time.
For sure.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast,
Give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about embracing digital transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.